Okay, welcome to I Know What You Did Last Shift, what a smart battery charger in a Class 3 lift truck can tell you. I'm Conway. I'm the Sales Application Manager at Delta Q Technologies. What that means is I'm the Senior Customer-Facing Technical Resource at Delta Q. And by senior, this is my 6th PROMAT. I was the first Delta Q person to walk a PROMAT in 2009. At the time, we were virtually an unknown, and mostly I was just a nuisance at a bunch of booths. So today, we're a little more known. We're in a few different markets, but still a bit of a nuisance, I am. What I'm going to talk about today, and what I'm hoping that you will get out of this, is what the data that a smart battery charger can tell you about any electric machine, but we'll use some lift truck examples today. Okay. I'll also talk about how we get that data out, and then how to use that data to your own benefit or your customer's benefit. So we're already using telematics with our battery chargers in some other industries. We see aerial work platforms up there, floor cleaning, and then other things you might already be familiar with, like cell phones, car sharing. These all have telematics in them. They're all in use today. So the dream that we have as Delta Q is to be part of that, right? We want to have the charger as part of the telematics solution for lift trucks. We're already using this charger today, the data from the charger today. Okay, we're using that data from the charger today to help prevent repair and service calls. We're already using this charger today to help enforce warranty claims. And we're already using the feedback from this data to enhance user experience, improve our products and our algorithms. I'm going to share 3 charger stories today. These are 3 different chargers doing 3 different things, and what that data tells us happened to that charger. Right? We're going to start with telling you a little bit about the data on chargers. While it's charging, our particular charger, but any charger in reality, could record voltage, current, temperature, AC voltage, and our charger, in fact, records a lot of other little things that you don't want to know. But we do, right? An interesting feature is off charge. A IC series Delta Q charger will also record the voltage about every hour or so, but really when the voltage makes a big change. Okay, so that's an interesting feature. There's no real-time clock on our chargers because we don't want to deal with changing a lithium coin cell in a sealed battery charger. It's not something that we want to do. But it's already been useful, the data, without a real-time clock. Okay? So let's look at charger number 1. These aren't real photos of the charger. These are representative photos. We'll call them Mo. And this was a field trial. I think they were using a new battery. I don't remember all the exact details, but I did get the charger data back from them. And they asked us to look at the data, tell us what the charger was doing, if everything was okay. The customer said everything was just fine. So we took that data and we plotted it. So here's kind of looks like a bit of a mess. But I mean, instantly, my trained eye sees the pattern, right? I don't know if anyone else sees the pattern here. Any beautiful minds out there see the pattern? Okay, so this is good regular use. Right? We have 5 days of use recorded by the charger, Monday through Friday. And what we saw was the truck on use about 3 or 4 hours. So you can see that voltage come down. On the left side is the voltage per cell. It ranges from 1.9 up to 2.8. So that voltage is pulled down to about 2.1. So it's not too deep of a discharge. And then that time scale on the bottom is about 12 days or so. Okay, so we're seeing 5 weekdays of use and then 2 days off on the weekend. And again, the same pattern repeats and repeats. Okay, so this is really good data. They would leave this charger on charge about 20 hours, use the machine about 3 or 4 hours. So every day, the exact same time they were plugging that charger in. And the exact same time they were using that truck. So very good, consistent usage. Okay, so no problems here. Mo is doing fine, and we may have prevented a costly service call. So let's look at a case where things were not quite as regular, okay? Charger number 2, call it Edna. Again, I think this was another field trial where they sent the charger data back to us and say, hey, what's going on? Is everything okay? The customer was not really complaining about anything, but they wanted us to have a look at the data and see what was going on. So that is not a regular pattern of use. Okay, this is a very irregular pattern. The time scale on the bottom is about 3 to 4 days. And you can see the voltage range stretches a little bit. It's not quite as high. Okay, so there's 2 things that I instantly pick out of that. One is there's no regular usage pattern here. It looked like it was in use 24 hours a day. I'm not an expert in warehouse operations or even how a lift truck is used usage pattern-wise. But what we saw as the charger is that very short uses, maybe an hour or 2 or 3, and then plugged in for a very short amount of time, maybe just 1 or 2 hours, and then pulled off again. And that cycle just continuously repeated. Okay, so the interesting things to pick out, if you're a battery expert, is that voltage does not really get very high. Like, it doesn't really skirt up above 2.6. So it's pretty safe to say that the battery is not really getting fully charged ever, okay? And what we saw here was about 20 disconnect cycles. So very frequent use, and so our conclusion here was that this needs a bit of attention, okay? There's a real potential here, especially if you were to talk to the battery manufacturer. Maybe that battery is being undercharged, chronically undercharged, and we're only looking at 3 or 4 days here, but if this were a pattern that stretched out to weeks, you'd probably see a battery that would have a very short life after that. Okay, so this one gets a flag. It definitely needs attention. So maybe the user could have been notified somehow to either change the pattern, or maybe they need a second truck, or just leave it plugged in for more. The other thing that we also see, which probably didn't happen here, was we get a couple of cases where the building power just gets shut down overnight, or the plug that the charger is on gets shut down at night for some reason. So we see a lot of that too, which interrupts the charge, and then things just start to go downhill from there. If you think that was bad, we've got an even worse case here. So we'll call this one Pat, because chargers aren't supposed to have a gender. But here's the pattern for this third one. Okay. So it looks a little bit like that. The time scale on the bottom is about a week. This went about 8 or 9 days of data. So what you're looking at here is you're looking at the first 2 days of, again, frequent use, connections on charge and then off of charge. The voltage being pulled down quite low, actually down to 1.85. So that the charger's recording that too. And then it's being charged up to above 2.6, which might be okay, might not. Okay, so 2 days of real hard use, and then 2 days off. And then back on again for about 48 hours of good use. Looks like it was left on charge a couple of times for a bit longer near the end. And that's, at the end of that, is where something kind of strange happens that the charger happened to catch and would have been good to know immediately. And that is that at the end of that last use, where it gets pulled down to 1.85, it does not get plugged in. The charger does not get plugged in. The truck is discharged, and it's left for what looks like about 2 days. Discharged, parked. And then after those 2 days, somebody comes up to the truck, starts it up, tries to use it, pulls it down to 1.8 volts per cell, which may be a limit, or maybe they realize that something was wrong, that this battery was already discharged, and then they plugged it in and ran away or something, because we had no data for 2 or 3 days after that. So somebody had used the truck, left it, maybe somebody else came back, found the truck was dead, plugged it in, and then the truck was abandoned. And the charger captured all of this. So this is kind of a user use pattern that the charger can pick up, and it could be notified to another device. Okay, we'll talk about that next. Right, so Pat, this charger needed a voice. We've had other cases like this where we're able to help enforce warranty because of the customer usage pattern. Okay, so wow, right? Great data. How do we get that out of the charger? Well, for our chargers, we use USB. Other chargers have other devices, either like a proprietary plug or Bluetooth or Wi-Fi or something like that. But our chargers are on board, so we use USB as the direct method of pulling data out. That gets plugged into a big data table that gets used on a PC. This is very simple, basic stuff that most people would need, like a technician could go into a little bit of detail here and look at the amount of charges it did, the charge times, the amp hours that it ran, all that sort of basic info. So for the people with engineering degrees, we have a more sophisticated IC data analysis tool with the full graphing feature, a lot more data, but just for our OEM engineers mainly. But our preferred method of getting that data out is via CAN, okay, because this allows you to connect the charger to the rest of the truck and therefore into the telematics. You can use a dongle like this maybe to get it out via CAN, plugged into a PC directly, but really our preferred method is through a telematics box. Right? So we have setups like this already today in those other industries I talked about, floor cleaning, aerial work platform, where the charging data is sent to a telematics unit, usually an optional box on the machine. And that goes through the cloud, back to the OEM headquarters, and then maybe back to us for some feedback. This path actually also works the other way. Okay? It also works if we need to do something to the charger, upgrade, add a feature, change something, reflash something. We can provide something through the OEM, back through their telematics system, back into the charger. So to sum up, what I want to say first is all we looked at today was voltage. And that's all we looked at. Just one piece of data from the charger told us that much. Okay, so there's a lot of other data points that the charger is collecting. Like I said, temperature, AC voltage, that can inform us of a lot of other conditions that might be going on with the truck. But just looking at voltage is what we were able to get from what I showed you today. So that data enables you to plug that into a telematics system, add to your fleet management, maybe help with that warranty support and enforcement. And if you feed it back through us, improve that user experience. We can also do some adjustments to charger software or algorithms based on that feedback, right? So this is all good stuff. So the message I want to send you away with is to listen to that charger, the data that the charger has, and use it to your benefit. Okay, thanks. I'll take any questions if there are any. Yeah. Any other warning systems aside from the USB? Well, because the charger is basically a standalone box. The only thing it can do is display something on the display lights, right? We don't have a siren or anything included in the charger. Right? We would rely on the OEM to read the data from the charger and then alert the user separately. Mm-hmm. So you want some kind of notification aside from USB. Well, that's the CAN bus, right? So CAN is another communication port on a charger that you could pull data from and use that to alert of any issues. There's alarms and faults that can be broadcast over CAN. Thanks. Anything else? Okay, if not, I'll be here available for any of your individual questions or battery charging issues, autographs, things like that. Thank you.